Okay, so in this question, we know that angle 1, the measure of angle 1, is 105 degrees. So we're going to just look at vertical angles, linear pairs, and corresponding angles, and we can find every other one of these things. Also implicit in this diagram, but it's not quite shown, is that these lines are parallel to each other. So, vertical angles. We know vertical angles are always congruent. So, from this 105 degrees right here, what's vertical to it is this angle 4. And since they're always congruent, that would mean that that's also 105 degrees. Now, if we want to look at linear pairs, so like angle 1 and angle 2 are linear pairs because they're right next to each other and they make a straight line. So those have to add up to 180 degrees. So 180 minus 105 gives you 75 degrees. Now, 105 is also a linear pair with 3, and also angle 2 and angle 3 are vertical, so they have to be the same. So in the end, we get 75 degrees right there. Now, if we want to bring this down here, since these lines are parallel, when the lines are parallel, we know that the corresponding angles are congruent. So corresponding angles, like this angle 1, this corresponds to number 5 down here. Like you can kind of think of it like how it's the top left angle on this little intersection. Angle 5 is also the top left angle on this intersection. So since the lines are parallel, this is also 105 degrees. And you've seen this diagram before. It's right here. 105 is vertical with the 8 right there, so that's also 105. And it's linear pairs with 6 and 7, so those are both 75. Now the real key with this is it opens up a whole bunch of other stuff once the lines are parallel, and it's crucial that these lines have to be parallel for these relationships to exist. So the alternate interior angles, like angle 3 and angle 6 for example, those are congruent to each other. The alternate exterior angles, like angle 1 and angle 8, those are also congruent, 105 degrees. If you look at the same side interior angles, like 4 and 6, that's 75 and that's 105. The same side interior angles actually end up being supplementary when the lines are parallel. So here, this is going to be really important to copy down. No matter what, linear pairs are always supplementary. And to show it on the diagram, I'm going to use one arc for that angle, and its linear pair, I'm going to use 2 arcs. So the fact that they have different number of arcs means that they're not congruent to each other. So vertical angles, no matter what, those are always congruent. And for vertical angles, since they're congruent, I'm going to use the same number of arcs. So like this angle is vertical to that angle. 1 arc means they're congruent to each other. Now, all the stuff on the bottom is dependent upon whether the lines are parallel. So everything up here is always true. And everything down here is only if the lines right here and here are parallel. So the alternate interior angles, those are congruent to each other. We just showed it earlier. That's congruent to that. Alternate exterior, also congruent. So like this angle is congruent to this angle. Same side interior angles, same side supplementary. One way that you can probably remember that, same side supplementary. So like this angle gets 1 arc, that gets 2. And corresponding angles we showed earlier, those are also congruent. Just ones to focus on specifically, the ones we're going to use the most. We'll use these a lot, obviously. I mean, because that relationship is always true. And the alternate interior angles and the corresponding angles also come up a lot.